All right, as we start today's lesson is on relationships between quantities. I just want to again remind you, pause the video if you need to, make sure you get all the notes, or if you need to rewind and go back and make sure you understand something, please do that. And as always, if there's something you don't understand, please let me know and I'll help you understand it. So this first part here, Lisa is 63 inches tall. With shoes on, Lisa will be taller, but how much taller? Well, right away you think, well, it depends on how high her shoes are. So the first question there, what are the three quantities in this problem? Well, the first one is Lisa's height. And then the next part it asks is, does it vary? Well, Lisa's height is not going to vary in a short period of time. Okay, so our answer here for Lisa's height is no. Okay, she's going to, whatever height she is, that's the height she's going to be the whole day that we're talking about this. Obviously, if we're talking about a longer period of time, that might change. The next quantity is the height of Lisa's shoes. Now, that does vary, because she could put on some taller shoes, she could put on some shorter shoes, so that's going to vary. And then the last quantity in this problem is Lisa's overall height. And yes, that varies as well, because it's going to depend on how tall the shoes are that she has on. The taller the shoes, the taller her overall height, and so on. All right, so now the next question here is, as the height of Lisa's shoes increases, does Lisa's overall height increase or decrease? Well, her overall height is going to increase. The taller the shoes are, the taller her overall height is going to be. The next question, as the height of Lisa's shoes decreases, does Lisa's overall height increase or decrease? Well, if the height of the shoes decreases, so will her overall height. And then we have this table here, and it says Lisa is 63 inches tall. With shoes on, Lisa will be taller, but how much taller? So if you look at the top row, those are all 63s, because like we said in the first one there, Lisa's height does not vary. Her height is going to be the same the whole time. The height of her shoes, again, that can change. So if she does, 0 would be if she didn't have shoes on at all. And then of course if she has shoes on that are 1 inch tall, 2 inches tall, 3 inches tall, that's going to change the third row, which is her overall height. So if she is 63 inches tall and she has no shoes on, then her overall height is still going to be 63, because 63 plus 0 is 63. If she puts on shoes that are 1 inch tall, well, now 63 plus 1 is 64. 2 inches tall for her shoes, 63 plus 2 is 65. 3 inches tall, 63 plus 3 is 66. So you can see how her overall height is increasing as the height of her shoes increases. Now the last thing we're going to put in here for the height of Lisa's shoes is an S. Okay? So now, think about what we've done here. We've always taken her height plus the height of her shoes to get her overall height. So 63 plus 1, 63 plus 2, 63 plus 3. So I'm going to do the same thing with the S, except I can't add those together, so I just write 63 plus S. That's all I can do there. So the algebraic expression that represents Lisa's overall height is 63 plus S. The last part there, the formula that defines the relationship between Lisa's overall height and the height of her shoes, is her height is going to equal 63 plus the height of her shoes. So H equals 63 plus F. Here's a picture of a problem we're going to do here in just a little bit, but on the left here you have one cup, and what it's showing you is that the height of the cup up to the lip is 7 centimeters. And then the lip of the cup is 1 centimeter. So on the right, they're showing you that when you stack up 5 cups, the height of that stack is going to be 7 centimeters for the height of the first one up to the lip. And then you'd have the 5 lips of the cup would make up the other 5 centimeters. So you would have 12 centimeter, a 12 centimeter stack when you stack each cup inside the other. Okay, and then just some examples and definition on these slides. I'd like you to pay attention to the definition of a quantity here. Whenever we say quantity, that's an amount that can be counted or measured. Okay, and then in the example, it just shows A equals B times H. Remember, that's the height, or that measures the, that's the formula for the area of a rectangle. Same with the next one, that is the relationship for the perimeter. Okay, this is just going over the situation with Lisa here again. So if you'd like to take a look at that, you sure could. Pause it and take a look. And again, this is just more on the problem we went through with Lisa's height and the height of her shoes. Okay, so this brings us to the problem with the cups. Okay, again, the height of the cup up to the lip is 7 centimeters, and then each lip is going to be 1 centimeter as well. All right, so taking a look at the cup problem here, there's 2 quantities that vary in this situation. The first one is the height of the stack of cups, and then the second quantity would be the number of cups in the stack. And then so part A is asking, do these quantities vary in relation to each other? So what they're asking there is, as one of them increases or decreases, does the value of the other also increase or decrease? And the answer is yes. The height of the stack varies in relation to the number of cups in the stack. The more cups that are in the stack, the higher the height of the stack will be. Less cups, the lower the height of the stack is. And then part B, how is this relationship between these quantities similar to the relationship between Lisa's overall height and the height of her shoes? Discussed at the beginning of the lesson. Well, as one quantity increases, the other quantity also increases. So just like when the height of Lisa's shoes increased, her overall height increases. Same thing here. The more cups we put in the stack, or as we put more cups in the stack, the overall height of the stack increases. All right, the next question's here. We're still talking about the table on the previous slide. Lisa found how much the overall height of the stack of cups increased as each cup was added. What error did she make? Well, she's looking at the first 3 columns, and she notices that the height changes by 4 centimeters in the first 3 columns. So she's assuming that the stack of cups must increase by 4 centimeters as each cup is added to the stack. Well, the problem with her reasoning is that she did not notice that the number of cups in the table does not increase by 1 cup. If you look at the table, in the first column, it's 1 cup is 8 centimeters for the stack, but then it doesn't go to 2 cups, it goes to 5 cups. And then 5 cups, the height of the stack is 12 centimeters. And then the next column is 9 cups. It goes from 5 to 9, and the height of the stack is 16 centimeters. So it's not going up by 1 cup in the table each time. Part D, how many cups are in the stack if the overall height of the stack is 57 centimeters? Well, if you look on the table and find where the height is 57, you'll notice that that's 50 cups. And then part E, just choosing 3 or more values here for the number of cups in the stack and the corresponding values for the height of the stack. So I just threw in 3 that were not on there. 2 cups, the height is 9. 7 cups, it would be 14. 4 cups, it would be 11 centimeters high. Again, you could throw in any 3 there that you would like. All right, now looking at number 3 here, says look at the diagram of cups on page 49 and the table in problem 2. Describe a rule for finding the height of the stack. Well, the height of the stack is just taking the number of cups in the stack and adding 7 to it. Okay, you notice that if you look at the table, when we had 1 cup, the height of the stack was 8. 1 plus 7 is 8. When there was 5 cups, the height of the stack was 12. 5 plus 7 is 12. Okay, and that pattern continues. Part B, we just need to choose some variables to represent the height of the stack and the number of cups. So I just went ahead and chose H for the height of the stack and N for the number of cups in the stack. And then part C is just translating our verbal description from part A into a mathematical formula using the letters that we chose for part B. So that would just be H equals N plus 7. Again, H is the height of the stack, and N is the number of cups. So if I take the number of cups and add 7, that will give me the overall height of the stack. All right, to close this out, how does a formula represent a relationship between quantities? Well, a formula states a mathematical rule for how one variable quantity depends upon the other. If we think about Lisa's height, her overall height depended on how high her shoes were. The taller her shoes, the taller her overall height. If we think about the cup problem, the more cups in the stack, the higher the overall height of the stack was. Okay, so in both of those, the one variable depended on the other. In this case, for both of ours, it was the overall height depended on. In Lisa's problem, it depended on the height of the shoes. In the cup problem, the overall height depended on how many cups were in the stack. Your homework is online on the Pearson site. Again, once you are done with the homework online, please hand in the note sheet as your way of telling me that you've completed the assignment.